Question 16. Figure 6 shows a sketch of the curve C with parametric equations x is equal to 8 sine squared t and y is equal to 2 sine 2t plus 3 sine t, where t is between 0 and pi over 2. The region R, shown shaded in figure 6, is bound by the curve C, the x-axis, and the line with equation x is equal to 4. Part A, show that the area of R is given by the integral between 0 and a of 8 minus 8 cos 4t plus 48 sine squared t cos t dt, where a is a constant to be found. Well, firstly, if we are looking to find the area under a curve, hopefully we're thinking integration. And so we would think to write the integral of y with respect to x, and this is between the limits of 0 and 4. Now we do not have a function of y in terms of x, we have parametric equations. And so this integral of y dx can be written as y dx dt with respect to t. But this is a new integral, and so this will have new limits, which we will need to find. So let's start by finding those limits. Well, our first one was between the x values of 0 and 4. So when x is 0, I can put this into my equation for x here, and so that is 8 sine squared t is equal to 0, which is sine squared t is equal to 0, which means sine t is 0, and so t is 0. So a there would be 0, which is good, that's what I want anyway. Let's look at when x is 4. When x is 4, that 8 sine squared t is equal to 4, and so dividing both sides by 8, sine squared t is equal to a half. Square rooting that, we get sine t is equal to 1 over root 2. Now, of course, this would be plus or minus root 2, but if we think to our cast diagram, we are in the first quadrant here, and so we're taking all positive values of t. And so sine to the minus 1 of 1 over root 2 gives us a t value of pi by 4, which is also in our range that we are given. Now, I need to find dx by dt in order to rewrite this integral. And so x is 8 sine squared t. Differentiating this, we times the 8 by the power, so that's 16, reduce the power by 1 sine t, and then we multiply by the derivative of sine t, which is cos t. So this differentiates to 16 sine t cos t. Now I'm going to use an identity here to rewrite this 16 sine t cos t. Our double angle formula is that sine of 2a is equivalent to 2 sine a cos a, and so this is equivalent to 8 sine 2t. If I now substitute in these values I have, so for y, 2 sine 2t plus 3 sine t, for dx by dt, 8 sine 2t, and our new limits of 0 and pi by 4, my current area R is looking like this, which is not quite where we need to be, but we are getting there. And so starting from this point here, let's expand these brackets. So 2 sine 2t times 8 sine 2t is 16 sine squared 2t. And then that's plus 3 times 8, 24 lots of sine t times sine 2t dt. I'm going to use a second identity here. That is that sine squared a is the same as a half of 1 minus cos 2a. I can use this to rewrite this 16 sine squared 2t as 8 lots of 1 minus cos 4t plus 24 sine t. Here I'm using the double angle formula from previous, so that is 2 sine t cos t. Expanding brackets now, that is 8 minus 8 lots of cos 4t plus 48 sine squared cos t, and that is what we want to show. Part B, I want to find, using algebraic integration, the exact area of R. Well, we now have R to be this integral. Now, integrating 8 is not a problem. Integrating minus 8 cos 4t is another nice integral because we know minus cos integrates to minus sine. But this 48 sine squared t cos t is possibly going to cause us a few more issues. Now, with the trig functions if we have 1 to a power multiplied by its derivative. So I can see here that cos is the derivative of sine. Then I know I can use integration by inspection. And so if I consider that this sine squared is going to integrate to give me sine cubed, if I let u equal sine cubed t, if we differentiate this, then du by dt would become 3 sine squared t times cos t. Now this is 1/16 of what we want. And so we can use this when integrating 48 sine squared t cos t. There is a link to another ExamSolutions video on this topic if you feel you want a little bit more information. And so coming back to our integration, 8 will integrate to 8t, minus cos integrates to minus sine. I do need to divide by the derivative of 4t, which is 4. So this is minus 2 sine 4t, and then plus, as we mentioned here, we've got 1/16 of what we had originally. So what we would like is for this to be 16 sine cubed t. Now this is a definite integral with limits, and so to find the value you substitute in the upper limit and then subtract substituting in the lower limit. So that is 8 times pi by 4, 2 pi, minus 2 lots of sine, 4 times pi by 4 is pi, plus 16 sine cubed of pi by 4. And then that's minus, well, 0. Sine of 0 is 0. Sine 0, 0. And so we're left with this here. That's 2 pi minus sine pi is 0. On a calculator, you can evaluate this carefully to be 4√2. And so our answer, the exact area of R, is 2 pi plus 4√2.